In this challenge, you'll be using the terminal operations shown on this slide in combination with some of the intermediate operations you've learned about. You'll be using these operations to answer questions about a series of students. If you skip the last setup videos, start by downloading and getting familiar with the code in the Student Streaming project, which is included in the Resources folder. It contains a student class with demographic data. This class has a factory method to generate a new instance of a student using random data. This factory method will also generate some random activity for each course passed as an argument to the student constructor. Your challenge is to create a source for a stream of students. Use the static method on student as the supplier. Use a large enough number to get a variety of student data, no less than 1,000 students for example. Use a combination of the intermediate and terminal operations we've covered so far to answer the following questions. How many male and female students are in the group? How many students fall into the three age ranges, less than age 30, between 30 and 60, and lastly, over 60 years old? Use summary statistics on the student's age to get a better idea of how old the student population is. What countries are the students from? Print a distinct list of the country codes. Are there students that are still active and have been enrolled for more than 7 years? Use one of the match terminal operations to answer this question. Next, select 5 of the students above and print their information out. Imagine that maybe you'd like to send them a special coupon for being long-time learners and clients of yours. Don't forget you can use Peek to help you understand your stream processing if you don't feel confident about your results. Okay, so it's time for you to give this a try. When you're ready to compare your code with mine, or you get stuck, come back and I'll show you my solution. Pause the video now. Welcome back. How'd you go with that? Were you able to answer some or all of those questions using the terminal operations on the slide? In the last video, I was working with the Streaming Students project, and I'll continue with that project now. If you didn't watch the setup videos, make sure you review this code, or at least take a quick look at the class diagrams in the slides of the first setup video. In the code in the main method, I use stream.generate to generate 10 random students, each taking both of my courses, the Python masterclass and the Java masterclass. I'll run this code so you can see those 10 random students and get a taste for the data you'll be querying. My students have a country code, a year enrolled, the age they were at enrollment, a gender, and a programming experience flag. In addition, you can get the current calculated age of a student with the method getAge. Course engagement is tracked with a course engagement type for each course the student is taking and is in the student's engagement map field. For this exercise, you can just call the getMonthsSinceActive method on the student to understand the last time they had any activity. It returns 0 if they've had activity in the current month, 1 if it's been over a month, 2 if it's been longer than 2 months, and so on. I'm going to comment out that stream.generate code before I add any more code. To start with, I'll generate 1,000 students and then answer the question, how many male and female students do I have? I'll assign my stream without the terminal operation to a local variable. I'll use the same lambda as before, getting random students from the static method student.getRandomStudent. I'll pass both courses to every student, so each student is enrolled and has activity for both courses. I want 1,000 students for these tests. Next, I'll add an intermediate operation to that stream variable. I can continue to add intermediate operations before I call the terminal operation. I'll filter on the gender where it equals M. The options are M for male, F for female, or U for undeclared. I'll print out the number of male students by executing the terminal operation count on my male students pipeline. If I run this now, obviously the results are random, but I should usually get something like a third of the population being male, so that's a good random distribution. Look at the code here on line 27 and notice I'm reassigning my male student stream to the result of that intermediate operation. What happens if I don't do that? Let me change that and see what happens, because it seems like if that's a lazy operation, I wouldn't need to assign this result to this variable. I'll remove male students equals from that statement. Running this code now to confirm what happens. I actually get an exception now. It turns out that when I called the intermediate operation on male students, even though it's not a terminal operation, it invalidates the existing stream reference. This means if I'm setting up my stream pipeline bit by bit, I need to always use the resulting reference to the new stream returned from each intermediate operation. IntelliJ does warn me of this, but I did want to point out this issue. I'll undo that change. Next, I want to see how many female students I have, but I already know that using this pipeline again will give me an error. Rather than creating a new stream of 1,000 students for each of these questions, I really want to test the same set of students. In an upcoming video, I'll show you how to create a collection from a stream pipeline. Right now though, I'll just do this with an array before I execute my stream pipelines. I'll insert this code on line 23. I'll instantiate an array of 1,000 students. I'll use arrays.setAll, passing it my students array. This lambda is an int function, so I have to set up a parameter, and here I stands for an integer. However, I don't really have to use it, and in this case I'll use the code I had before calling student.getRandomStudent, passing the two course instances. Now instead of randomly generating my 1,000 students each time, I'm doing that once, then I can ask all my questions against that array. For the male students, I'll remove that set of first statements altogether. I'll start again, this time with a stream, using the students array as my source. I can get a stream from an array using arrays.stream. I'll use the same filter, but this time I'll just chain it. This compiles and runs, and I get basically the same results, remembering the random nature of the students generated into the array. To query all the genders, I'll set up a loop to process a pipeline for each gender. I'll loop through the possible options using list.of to create an iterable collection. I'll set up a local variable in the loop called myStudents and do the same thing I did previously, creating a stream from my students array. I'll filter this by the loop variable now, and I'll print the loop variable and the students filtered by that. That looks and feels more concise, and running that now, I get counts for all gender types. Totaling that up equals the total array length of 1,000. In the next piece of the challenge, I want to group my students by age, but my ages are ranges. I'll do something similar to what I did with the gender groups, but instead of iterating over a series of string values, I'll iterate over several predicates. This means I want to set up a list for several lambda expression variables. I'll create a list for predicate variables, and these will operate on student. Each will have a parameter, which I'll call S, which will be a student type. Here, I'll specify the student as the type, just to remind you that this is another valid way to set up a lambda expression and can help sometimes with readability. This time, I'm going to only use two conditions because I can calculate the third without iterating through my set of students again. This won't matter with just 1,000 students, but processing an additional stream pipeline unnecessarily could be detrimental to performance if you are processing large amounts of data. I'll create a local variable for total that will be long, since the count operation returns a long. I'll use a traditional for loop here. I'll again get my students, but this time I'll pass the predicate from my list using the get method with the current loop index. I'll assign the result of the count operation to a local long variable. I'll keep a running total of students matching my criteria. I'll print this out with a formatted string and use a ternary operator to print the ranges. Finally, I'll print out my last category, which is what's remaining, the students greater than or equal to 60, and that's the array size minus the total here. Running this code, I get what looks like a skewed set of numbers, with my students who are over 60 always being the largest bucket, and the ones under 30 account for only about 1/10 of my population. First, don't forget, all of these students, at the time of enrolment, were 18 or older. In addition, this code isn't checking the enrolment age, it's checking the current age. Remember, some students enrolled over 5 to 8 years ago. Each bracket also spans a different number of years, so the first is really 18 through 29, or just 12 years. The second bracket is 30 years, and the last may have ages that range from 75 to the late 90s because of the elapsed years, so it's a much larger bucket. I'm going to stop this video here, and I'll pick up the remaining parts of the challenge in the next video. I'll start with a way to examine statistics about numerical fields, like this age field we've just been looking at. See you in the next video.